Hello, we are now looking at section 4.3. So after completing this section, this portion AB of the 4.3, you should be able to do your homework 4.3A and 4.3B. So this is about logarithmic functions, and remember or recall that every exponential function f of x is equal to a to the x with a greater than 0 and a not equal to 1. I explained that why we have to keep these conditions on a. Now if you recall, it is a one-to-one function. So what is a one-to-one function? A function, basically, how do we check one-to-one function? Now let me draw the graph of the exponential, maybe over here. So the exponential function looks like this. This is 1 here, and this one goes up very fast depending on the base a. So this is the exponential function, and if I draw a horizontal line, it will cross the function only once. That's why it is a one-to-one function. Horizontal line test is the test for checking that the function is one-to-one. What does one-to-one mean? It means for one x value, there is one y value, and that y value is only for this x value. Just quickly, 1, 2, 3, if we have a set 1, 2, 3 which is being mapped to a, b, c. So if I do 1 to a, 2 to a, and 3 to c, this is a function, but it is not one-to-one, because the image a is the image of two of the domain values, so the first set value or the input values. So each input should go to an of course input has to go to an output, but a unique output. So, and if we do a 1, 2, 3 here and a, b, c, 1 goes to a, 2 goes to b, and then 3 goes to c, then it is a one-to-one function. So now we define the log function to be the inverse function of the exponential function. Now if you recall, the inverse functions, the graphs of the inverse function are actually we say that they are the reflection of the function about the line y is equal to x. So again, let's draw this. Let's put a 1 here and a 1 here. So the exponential function is looking like this. Now the line y is equal to x will go like that. So if you reflect this about the line, so any point, so for example, if we are looking at 3 to the x, so we have a point 0, 1 here, so that will become 1, 0. Okay. So the point 1, 3, at 1 the value will be 3 for the exponential function, it will become 3, 1. So 1, 2, 3, at 3 it will be 1. So this is, and then at 1 over 3, we will have a value negative 1. Y value will be negative 1. So now you can see, you draw the function. This is how the function looks. So this is, so if this is y is equal to 3 to the x, then this will be y is equal to log base 3 of x. Now if this is y is equal to 2 to the x, then the corresponding logarithmic function is going to be log of base 2 of 3, of x, y is equal to x. or yeah, so this is what you have to learn, the conversion. So this is the, so these are separate. I mean, we can call this I shouldn't say y for both, that can be a little bit confusing. So let me call this the function f of x. F of x is 3 to the x, then g of x is going to be log base 3 of x. So now we define the logarithmic function. So as you noticed, if you have y is equal to a to the x, or f of x is equal to a to the x, then the g of x will be log base a of x. So a is the same a that we have in the exponential function, and it has the same condition that it has to be greater than 0 and it cannot be equal to 1. So now when we define our logarithmic functions, we say for a greater than 0 and a not equal to 1, the logarithmic function with base a denoted by log of x to the base a or log base a of x is defined as, we say y is equal to log, you can have the y on the left side or y on the right side, it doesn't matter. So you can read it like this, log of x to the base a, then this sign means if and only if, which means this goes both ways. So if we have log y is equal to log of x base a, then this can be written as a to the y is equal to x. And if I have a to the y is equal to x, then it can be written as y equals log of x to the base a. Okay. So now if you have something like this, y is equal to a to the x, so this is different than what we have here. So then you can write it as log base a of x of y equal to x. So you are not getting the same thing that we have here, because here also we had something different. Anyhow, so these are called, this is called the logarithmic form and this is called the exponential form. So we should be able to convert back and forth. So here is a better explanation. So logarithmic form, log base a of x is equal to y, can be transferred or is transferred like this, a raised to y equal to x. So note here, what is this y? Y becomes the exponent of the base when you convert it into the exponential function. So let us first practice some conversions. So this is the logarithmic form in the first line. So when I convert it to the exponential form, first one, log of a to the base 2 is equal to 3. We write it as 2 to the 3 is equal to 8. So notice here, this is also like a way to convert the base raised to the power, which is on the other side of the equal to sign in the logarithmic form, equal to 8. So what it is saying is that when 2 is raised to the third power, the answer is 8. Okay. Log base 10 of 100,000 is equal to 5. So how will you write it in exponential form? 10, which is the base here, raised to the exponent, which is the 5, equal to 100,000, which is correct, right? If you cannot see it like here in there correct, at least you should be able to see this is correct. Because 10 to the 5 means 10 into 10 into 10 into 10, 5 times. When you multiply 10 5 times, you get 100,000. Now the next one is saying log base 2 of 1 over 8 equal to negative 3. So how will you convert? 2 raised to negative 3 equals 1 over 8. And similarly, the last one, log of 9 to the base 1 over 3 equal to negative 2. So we convert it to base raised to the power negative 2 equals 9. So if you note, basically what is happening is that this quantity is actually an exponent. Because remember again, y is equal to log of x to the base a, becomes a to the y. So what is y? Y is equal to this quantity, which is equal to, okay, now if x is equal to 10, now it is the other way. Now I have some exponential form. So these are exponential forms, and we are going to convert them to logarithmic form. Also, another important thing you will notice here, some logs are which are mostly used in our real life. They are the log base 10 and the log base e, where you see many problems with log base 2, log base 3 when doing the calculations or graphing. But the two logs and which you see on your calculator, the keys of these two are on your calculator. So the log base 10 is denoted by, so it is not written as log base 10, it is just written as log. So the log base 10 is the same thing as log, and log base e is ln, because it's called the natural log. If you recall, the function y is equal to e to the x was called natural exponential function. So similarly, here we call this log function natural log function. So ln x means log of x to the base e. So e is hidden, so but it should be in your mind. Similarly, if you see log x, it means the base is 10. But if you want to write log of x to the base 2, you must put the base there. Log of x to the base 3, 1 over 3, whatever, you have to put it there. So here, so in here, that's what I'm showing, that x is equal to 10 cube can be converted into logarithmic form if needed. But note here, if you get something like this, you cannot directly find x. You have to convert it into exponential form, and you can see what x is. But over here, it's just like the indication that log base 10 is log x. Log of x base 10 is just the log of x. Okay, so it is called the common logarithm and is denoted by log. So log of x to the base e is called the natural logarithm and is denoted by ln of x. This means in ln is log base e. Okay, so if we want to convert these into exponential form, can you see what will be? So this will be 3 to the 4 equals 81. This will be 8 to the 3 equals 512. This will be 8 raised to the power 2/3 is equal to 4. What is this one? Next one. So you see there is no base, so it means base is 10. So you say 10 to the 2 is equal to x minus 1. Now if you have to find x, you can easily find it from here, because this will give you x equal to 101. You can check. Okay, so next example 2. Express each logarithmic equation in exponential form. So ln of x is equal to 5. What does that mean? Ln of x, remember, means the base is e. So you will say e to the 5 equals x. In the next one, b part, ln of 2x minus 1 and parentheses is equal to 4. Now note here, if you see something like this, ln of 2x minus 1, then the negative 1 is not coming with 2x inside the log. So this is one term, and this is something added to, subtracted from that. Don't assume there are parentheses if there are none. There. So this will become e, because the base is e, to the 4 equals 2x minus 1. This one is saying express each equation in logarithmic form. So base is 10, exponent is 3. So how do we write it? If you recall, log base 10 of 1000 equals 3. Log base, what is the base here? 81. Log base 81 of 9 equals 1/2. Next one will be, I'll give you a few minutes to do C and D. So stop the video here, pause the video here, and try to find the next two. Then we will go from there. Okay, I hope you guys were able to write that. So what is the base here? 4. So how will you write? Log base 4 of 1 over 8 equals -3. D part, what is the base? E. So it will be log base e. Well, we usually don't write like this, but if at this moment, because if this is like new to you, then you may keep doing it. Log base e of 0.1 equals 3x plus 1. Okay, and then in the next step you should write this as ln of 0.1 equals 3x plus 1. Okay, now we are going to look at some properties of the logarithmic functions. So I'm doing it for a general base a, and then over here we are looking at the different bases, and we are going to evaluate those. So using these properties written in the green line. So the first property is that log of 1 to the base a is equal to 0. So if you convert it into exponential form, what will that be? It will be a to the 0 equals 1, which is true. Now this is saying log of a to the base a is equal to 1. So what does that mean? If you convert it to exponential form, you get a to the 1 equals a, which is correct, right? Okay, next is log of a to the x base a. So if the base and this number over here are same like in the previous case, but now we have an extra x on the as a exponent, then this will be equal to just x. Fourth property is that if you have a raised to log base a of log base a of x is equal to x. So these two are giving you back x. So, but the condition is that the base and this number to which is being raised to the power x should be the same. So, using these properties, we have to evaluate the following expressions in example 4. So, log base 4 of 1. So, which property will be used? The first one. So, the answer will be 0. So, what about the second here in the same line? Log base 3 halves of 1. Now remember what this property is saying, that log of 1 to any base is going to be 0. Log of 1 to any base is going to be 0. So log of 1 to the base 3 halves, 0. Log of 1 to the base, what is the base here? No base means base is 10. So this is 0. Log of 1 to the base 6, 0. What is this one? ln of 1. This is log of 1 to the base e. Answer is 0. Log of 1 to the base 1 half, 0. So log of 1 to any base is 0. Now what is do we have here? Log of 2 to the base 2. Which is that? That is the second property here. So base and the number whose log we are taking is same. So answer is 1. Here we have log of 4 to the base 4, 1. Log of 1 half to the base 1 half, 1. Log of 10 to the base, what is the base here? 10. So log of 10 to the base 10, 1. Okay, what is this? This is log of e to the base e. So answer is 1. So ln of e is 1. Log of 3.12 to the base 3.12, answer is 1. Okay, now the next one. So we will use property 3 here. So this is saying log of 216 to the base 6 is equal to what? So when you have these type of problems, what you should try to do is try to write this as a power of 6. So how would you do that? Well, you will, because you know that you have to write it as power of 6. So try multiplying 6 times 6. What do you get? 36. Okay, now do 6 cube. So this is 6 square. Now do 6 cube, which will mean 6 into 36. Multiply that. So you'll see that you get 216. So here I write it as log base 6 of 6 cube, and now using the property 3, I get 3 as the answer. Okay, next one, log of 7 to the base 49. Log of 7 to the base 49. So now if you can write 7 as some power of 49, then it's good. But if not, then I will show you a trick. Okay, by the way, so 7 can be written as 7 is equal to 49 square root or 49 raised to the power 1 half. So I can write it as log of 14 base 49 of 49 to the 1 half. So using the property 3, I get 1 half as my answer. But if you cannot see that, the easiest way to do it is say that because you have to evaluate this quantity and you don't know what it is, so just say that it is equal to x. Now convert it into exponential form. So this is what we get. Okay, now because the base is here is 7, so try to get this into base of 7. So this will be 7 square raised to the power x equals 7, which means 7 raised to the power 2x is equal to 7. Now when the bases are same, the powers will be same. This is one-to-one property of the exponential function. So we say 2x is equal to 1. So So x will be equal to 1/2. So answer here will be 1/2. In the same way, you can do the next few problems. So how would you do this one? This is log of, so remember the base is 10, so you have to write this as a power of 10. So what will that be? Count how many zeros there are? 5, so that goes up here. So log of 10 to the 5 base 10, answer will be 5. Okay, I will wait until you finish this line. Pause the video and finish the line. Okay, I hope you guys are back. So this is same as like the previous one. So here we have 2 raised to 1/2, but the log is base 4. So we want these two to be the same. Now changing this is not going to help much, because if you change this to 2 and write it as 2 square, we don't have any rule for that. So the best way to do it is, as I just mentioned, convert it into exponential form. Say that this is x, four to the x equals 2 to the 1/2. So now the smaller number is 2, to make both. Now you can do 4 as the base 2. So 2 to the 2x is equal to 2 to the 1/2. So which means 2x is equal to 1/2, which implies x is equal to 1/4. So answer over here is 1/4. Similarly, the next one, log of 2 to the base 8. If you can see that this is equal to log base 8 of 8 to the 1/3, then the answer is 1/3. But if you cannot see that, then you have to do this way. Okay, what about the next one? Well, we have base is 10, so I have to write it as 10 to the something. So 1/10 will be 10 to the -1, so answer will be -1. Okay, so this is how you do these evaluate these expressions. Okay, let's try to finish it. These are a lot, but let me do a couple of the next, and then you guys can finish on your own. So the next one here is log of 0.001. So what is the base here? 10. So it means you need to write this expression as 10 raised to some power. So it looks like it should be a negative powers, but negative what? -2 or -3? So how would you find out? You will count the number of places to the right of the decimal, and then there are 3 decimal places, so you say -3. Log of 10 to the -3. So then using the property 3, the answer will be -3. So this one is already written as a power of 10. So this is log of 10 to the -5 base 10. The answer will be -5. Okay, the next one is again similar to previous one. So set it equal to x, convert to exponential form, and both sides write them as base of 10, as powers of 10 with base on both sides. The base should be 10. This will be direct. It is -6. This will be direct because this is ln of e to the 1/2. So the answer will be 1/2. And the next one is direct, ln of e to the 23. So the answer is 23. So what will be the answer here? 4. Next one, log of 27 to square root base 3. Now, what is 27? 27 can be written as 3 cubed, and then you have the power of 1/2 on top. So what is the power on 3? 3 over 2. So answer will be 3 over 2. Again, if you cannot see it directly, set it equal to x and then make both sides as power of 3. Like base should be 3 and the powers will be different, then you equate them. Okay, you guys should be able to do that. Now the last line, so we are using property 4 now, which says if you have a raised to log base a of whatever quantity, you get back that quantity. So if you look at the first here, 4 log base 4 of 15, so answer will be 15. Here 10 raised to log base 10 of 87, so answer will be 87. This will be 8. What do you think about the next one? That will also be just 4. Okay, what about this one? The answer will not be ln of 2 plus ln of 3, because remember e to the log base e of a quantity is that quantity, but here we have to split it. So this can be written as e to the ln of 2 times e to the ln of 3. How and why? Because of the exponent rule. Because if you have x to the 3 times x to the 5, what do you say? What do? You say x to the 3 plus 5. So you will say x to the 8. So it means when in the same way, if I have a x to the m times x to the n, I can write it as x to the m plus n. So if I can go from here to here, I should be able to go from there to here. So that's what we just did. But the first one gives you 2 and the second gives you 3. So 2 into 3, so answer will be 6. Now this one. So this is not going to be 2 into 3. Okay? Because remember the rule is a number then raised to log of to the base a of something. So basically if you think, you have to do the same thing with this one which we did in the previous case, because it's 2 times ln of 3, so you can think of it as, let me erase this one. Okay, you can think of it as e to the ln of 3 plus ln of 3. So it is e to the ln of 3 times e to the ln of 3, which gives you 3 into 3 is equal to 9. So this is how you do these problems. Okay, now came the little bit tough one, the ones that you see in the exam, in the final exam. So whenever you have a plus or minus, so plus means multiplication and minus means division. So these actually show us some more laws of logarithms. If you have taken a course in which you learned about logarithms, maybe you already know those laws, but if not, then you will see them in this class. Okay, So so this can be written as e raised to ln of 10 times, because of the addition sign we have multiplication, times 1/2, no sorry, e to the 1/2 ln of 4. So what will you do now? Basically, I think that law needs to be known before you guys do this, but it's fine. Maybe we can hold on to these and do them later. Okay, we will come back to this later. Okay, I will stop the video here and then we will do example 5 and then we will come back here. So in the second video.